Okay, so today's notes, we're going to go through them together. I thought I could, record my voice over them. So you can see there's a warm-up. We're going to learn more about solutions, and the warm-up is if you have a crystal of a solute and you put it in solution and you stir and the crystal doesn't dissolve, what would you call the original solution? So what is it? Well, it's a saturated solution. Now, how do substances dissolve? Salt, which is an ionic compound, remember that means it's made of a metal and a nonmetal, and sugar, which is a covalent compound, which means it has no metals in it, will dissolve in water, but what happens during the dissolution is different. Dissolution means dissolving, the process of dissolving. Salt breaks apart into ions. Molecules of sugar stay together, but the molecules were kind of stacked on top of each other, and now they're spread out and become sort of invisible, so you don't see the crystal anymore. And what you should do here is you should stop and you should pull up link number 1 video, because that's going to show you an example of how things dissolve for salt and sugar. Okay, heats of solution. Exothermic heat of solution, it happens when something dissolves, it gives off heat. Okay, and I'm going to show you a video with an example. All gases have this property, and there are like a couple of ionic compounds that have this property. The video gives you examples of an example of one ionic compound that has that property. The key thing is the maximum solubility, that's how many grams will dissolve per amount of solvent for a gas, is lower at high temperature. And that's true for any other compound that has an exothermic heat of solution. Endothermic heat of solution means that when the solute dissolves, heat is absorbed from the surroundings and the solution feels cold. Again, they'll give you some examples in the video that you should watch next. The other key thing is that the maximum solubility of ionic compounds increases at high temperature. Almost all ionic compounds have endothermic heats of solution. Okay, so now you should stop. Watch the second video. The videos aren't very long, they're 2 or 3 minutes. Okay, now this is a graph of solubility versus temperature, which is sometimes just called a solubility curve graph. You will notice that all ionic compounds on here are going up. Everything is an ionic compound except hydrogen monochloride gas, ammonia gas, and sulfur dioxide gas. Now, they're gases until they dissolve, but then after that, they're in solution. You notice that every ionic compound, as the temperature goes up, more dissolves. Every gas, as the temperature goes up, less dissolves. So, the compounds that I just described, you can tell which have endothermic and exothermic heats of solution. Why? Endothermic, as it gets hotter, more dissolves. Exothermic, as it gets hotter, less dissolves. That's pretty straightforward. The key thing from this is you can see that temperature greatly affects how much will dissolve. It affects the solubility. And how do we measure solubility? Solubility is grams of the solute that dissolve in 100 grams of solvent at a given temperature. That's how a chemist describes solubility. So you will notice the scale here is in solubility. In this case, it's grams of the whichever compounder it is per 100 grams of water, because water is our solvent. Now, your homework assignment has to deal with this picture, a solubility curve, okay? So what is a solubility curve? You just saw a previous graph which also had solubility curves, but the solubility curve shows the lines that mark the maximum amount of solute that can dissolve at a given temperature. So that marks the line of saturation. No more can dissolve. So for instance, if you were looking at, let's look at ammonia and let's look at 70 degrees. Right here, you can see about 18 grams of ammonia will dissolve in 100 grams of water at 70 degrees Celsius. You can't dissolve more at that temperature. You could dissolve less. If you're right at 18 grams, that is a saturated solution. So it's the line of saturation. Below 18 grams, down here somewhere, then it is an unsaturated solution. Thanks.